Let's see. There we go. Inferential statistic. Yes, okay. No, stop that. Copy. There we go. Hey, what's up, man? How are you? Good to see you. Back for more. That's fun on Monday. We'll get started in a minute or two here. Where am I? Ah, here we go. Yay, fun. Hey, Lexi, how are you? I am doing well. But yes, we are week 8. Halfway done. Almost halfway done. So, hey, look at that. Yeah. So we got what, 100 topics? 54. A little bit more than halfway. So that's good. I did do my what is it? My progress, my knowledge check the other day after we got off the live stream. Or actually, I might have done that at school. Maybe I did. I can't remember. Yeah, I know. Halfway done. So my other 8-week course, the organizational behavior online one, the one that's 100% online, that one is just wrapped up on what was it, Sunday? It's yesterday. So if you had any of those 8-week courses, yay, those are done. So and if you're doing the ones with the 8-week course on the back half, man, those are brutal. So if you're doing any of those, good luck. But usually I try and do the I try and tell people if you're going to do any of the half semester ones, do them in the first half, because otherwise they butt into your what is it? All your finals with the larger ones. Man, where is everybody? I guess it's just us today, huh? Oh, there we go. We got a couple folks in there. So I was about to say, but that's okay. Trivia topic for today. What are we doing? So I am not picky. Whatever you would like to do, we will find something. So, but it is time to dive into the ERPLs here, random variables and distributions. So these should go pretty fast for you. So, but at the same point in time, also let me know what you're working on. But we will keep doing the live streams here on Mondays, so that I'll have videos for all the topics up there. But then also at the same point in time, the Wednesday sessions with the Zoom, don't worry if you can't make it to those, but at the same point in time, or if you're not on time or whatever, you can come in and check it out, and if you need some help, I'm there. But we will keep that up, all right, during those days. And so it's basically lab time. It's office hours. If you've jammed up on anything, come by, drop in on the Zoom. I will totally help you with it. Hey, Morgan, how are you? Don't worry about that. No worries. So we are week 8. We are getting to the very laid back part of the semester. So as long as your pie looks something like mine, you can take it a little bit easy. If you don't have these oranges or these these red ones knocked out, you need to get those done, all right, within the next week. Just because some of this other stuff that's coming down the pipe, some of these, particularly in the blues, there's a few topics in there. They do take some time to do. So, but at the same point in time, this is where I'm at. This is a good spot. If you're in this spot, great. So let's start some of the purples here, and I think I've intentionally left all of these blank. on mine. Let's go take a look. Yes, so I don't think I have any of these left to do, but let's just double check. Well, I mean, I don't think I've done any of these, except for maybe one of them. No, I have not. All right. So random variables and distributions. So the problems are going to be very, very different from this point on time in the class. And so I've got mine blank, so we can kind of go through them in a little bit of order here. Although there's not a perfect order to do them, there's easier ones and there's ones that are like, oh my God, what is this? So they're not hard. It's just one of those things that looks a little bit difficult. Food trivia. Yeah, okay, we can do food trivia. So I am not a foodie, so I can't really tell you. That is not something I can do off the top of my head. What the heck am I doing here? Here we go, learn. But yeah, we can do some food trivia. So, yeah, what is it? There's like, what is it? It's eat to live and live to eat kind of thing. I am very much so an eat to live kind of person. So, yeah, with the exception being, I don't know. I really love junk food. I'm a little bit of I can't eat it as much as I used to, but what is it up here in Colorado Springs? We got the new In-N-Out burger, and it is. I mean, I love that burger. So, we just can't eat it very often, man. It's not good for you. So, but yeah, like other things, I do cook quite a bit, but I don't. I mean, I couldn't tell you what goes into hollandaise sauce. I have no idea. But that's okay. Anyway, here we go. Random variables and distributions. Okay. Let's see what it's going to give us to start with here. So yeah, the first ones that you should probably do, maybe there's discrete versus continuous and then discrete probability distribution basis. So yeah, we definitely want to do this one. This is probably one of the first ones that you want to tackle in purple. And then this one right here, discrete versus continuous variables. This one's very easy, all right? And then when we start getting to discrete probability distributions, and then there's a few things coming down the pipe that are a little bit more difficult. The one that you should stay away from, at least until, well, you don't have to stay away from it, but if you do it, make sure that you're going over to Blackboard, is anything that says binomial problems. All right. So binomial problems, really straightforward. When we have a probability distribution, binomial problems are always going to ask you, so what are the odds of actually pulling out a random individual observation within the data set that is either less than this or greater than this? All right. If you do the problems with the formulas, they're a little bit tricky because you have to use combinations and permutations, or combinations, if I'm not mistaken. But there's a tool in Blackboard that makes these a lot easier. So we'll cover those probably next week. But let's get some of these classification ones out, because these are a little bit more conceptual, and they're probably a little bit more like, what is this? Okay, so let's jump into that here real quick. Let's start with discrete versus continuous variables. This one's very straightforward. You should do this one probably first. Okay, and so all it's going to do is ask you the difference between, well, is this variable, so it describes a variable here, is it discrete or continuous? And I'm just going to jump in here, and I'll explain it as I go. So a discrete variable is one that is actually a count, okay? And so anything that has to do with a count, same thing with frequency, discrete, they're all the same thing. All right, they're just depending on where we're coming at and what we're describing. We use slightly different terms, but it's all the same thing. So discrete, count, frequency, all the same thing. And so any variable that's a frequency or a count, it's a discrete variable. Anything that's measured, it's continuous. Okay, and so if it's a variable where we're measuring everybody's height, how many dollars are in, your wallet, like how old you are, stuff like that. So anything where there's a distinct measure that we can use, all right, then it is continuous. Now you could say, well, a count would be like, how many years old am I? That would be a count, would it? Yes, but not, it's something where we would take a look at several different people, okay? And rather than saying, saying, okay, you're this many years old or you're not this many years old, we would say you're 17 or you're 65. Okay, and so it is a measurement. All right. Whereas, so it's continuous. Whereas with discrete, it would be like, all right, okay, so let's take a look at how many people are in the room. How many of those individuals are men versus women? All right. So we would have men, women, and then we would just count up. Okay. And so that would be a discrete variable. And so you'll get the hang of it as soon as you go through these. So like the number of typographical errors in an edition of the Metropolitan newspaper, when it says the number, this is a count. Okay. And so we're looking how many of them are there. All right, so this one here, the temperature is always going to be a measurement, and so it's continuous. The number, again, I'm not even going to read the rest of it, count. This one, the number, again, count. So it's discrete, all right? And so that's all you have to think about on these ones. Are we actually doing a count here, or are we doing a measurement? All right, and that's all there is to these two things, okay? So you don't even have to read them all, all right? So here we go. The number, discrete. The total amount of time, well, the total amount of time being a measure, so that one's going to be continuous. Actual length, again, that one's a measure, so continuous. And the mass of solid impurities per milliliter, okay, yeah, that one's definitely continuous. All right, so understand, it's if it'll say number or count, and boom, that makes it discrete. Okay, let's do one more here, real easy breezy, and you should be able to crush this one out in 5 minutes. So the actual length, so length, of course, it's going to be measured in inches or feet or yards or meters or whatever. So whatever, it's a measure, so it's continuous. Fuel efficiency, so this is continuous as well. So that would be a measure, it'd be specifically a ratio. And then this one, the total attendance at public school on a single day. This one, a little bit sneakier, but think about this. This is a count, how many people actually showed up. So that one's going to be discrete. And same thing with this one, total amount of snowfall in Minneapolis this year. This one is not going to be a count. Check that out, a little sneaky right there. This one's going to be a measure, all right? So it'll be in like inches or something like that. So there we go. Check. Let's see. There we go. So watch that. Those are a little sneaky there, but usually it'll say either count or number, but just check this total one. I'm glad we got that one because I don't know if they had that one in there like that before, but there you go. So that's the difference between discrete and continuous. Remember, discrete, count, continuous, measure. So next. There we go. All right. You said food trivia. Yeah, no, that's fine. No worries, Matt. We'll be out of here pretty early today. We're just going to cover these 3 topics. And then whatever you guys are working on, that's fine with me too. So, but let's go ahead. We said food trivia today. Let's get one in here. Oh, let's see. I don't know. You're going to have to tell me what's hard and what's not. So with this, here we go. Let's see. Oh, no. Not that one. I need one with answers. Let's see. No. Oh. Okay, yeah, this will work. All right, so I found a site here. So this is kind of interesting. Which is the most expensive spice in the world by weight? Which is the most expensive spice in the world by weight? Go. So there we go. Iconic foods from the U.S., huh? So yeah. Where was pizza invented? I'm not seriously asking that. So no, the actual question. Yes, good job, Matt. You got it. So it's saffron. Aiden, you were very close. Just a little skosh behind there. So, but yes, saffron. How much is saffron? So I am curious. By the ounce. What? Oh, that's by the pound. All right, so, but still, that's a lot. $72.95 a pound. I bet you that's more than cocaine. Not that I would know, but I know who to ask. So, oh, that's okay. It's still saffron. So, almost thought bay leaves. Really? So I think I got some of those upstairs. I guess mine are dry, to come to think of it, so maybe that's a little bit different. But yeah, nope, Saffron, Matt, you got it in there first, so good job. Yeah, you're just missing one F, but that's okay. So yep, you are out. Or gold? Nah, gold's not worth that much right now, is it? Well, actually, it probably is. It's been a while since I've looked at it. Oh, come on. Let's take a look. Go to the good old standby here. $1,600 an ounce. Yeah, so that's a lot more. So yeah, okay. Gosh, you know what? That's actually pretty high. I remember, what was it, like, was it like 10 years ago? Or maybe it was like 2008 crash when all those like gold rush shows came out. Those idiots who were going up to Alaska trying to make themselves rich, and you know, then the like, what was it, 17-year-old kid knew more about anything than all of them put together. So, but I thought gold was like $1,600 an ounce way back then, and so maybe it's not necessarily good. So I wouldn't know, but I know who to ask. Yes, I do. So I do know who to ask. All right. So, and no, it's not because like, hey, I'm in the market. So, it's just so. No, I'm not gonna actually fill that information in. I'll just let your imagination go wild. So, but anyway, here we go. Let's see. Yeah, you can. I don't know about like. I mean, that's like. I mean, I've done gold panning. Man, there are way easier ways to make money. I'm sorry. You know, there are ridiculously easier ways to make money. I mean, you know, just go put $5 in a Bitcoin or something. I mean, I don't know. So it's like so much work for such a like small return. You know, and I mean, it's like, I mean, you can make more money gambling. So, I mean, I don't know. Anyway, I'm a little down on some of those, like, you know, oh, yeah, this is how you get rich, you know, kind of thing. It's like, no, actually, it's not that hard. You know, so, you know, you just want to do it really fast, all right? So that's the problem. I can't help you with that. So, but anyway, here we go. Back to Alex. Having too much fun just messing with you guys on this stuff here. So, but anyway, what were we doing? We were doing Erples. Give me my Erples back. All right, so the next one you should do after that one is this one: classification of variables in the various levels and levels of measurement. And that's because once you understand the difference between discrete and continuous, then when we're actually taking a look at different types of variables. Now, this won't come up too much in this class, but in 360, this is actually really important, okay? Because when you're actually setting up certain types of quantitative analyses, particularly like regressions and things like that, you do have to have one very specific type of data in order to be able to do that. And so once you understand the difference between discrete and continuous, so it's count versus a measure, then it breaks these down in some other different respects, okay? And so you're going to have this one, so it's going to give you the variable, then the type of variable, and you're always going to have the same two choices on each one. They see the quantitative or categorical. And so quantitative is a count, or it can be, it's something that we can use because it's something that we can do quantitative analysis on because it uses numbers, basically, whereas categorical, when we're talking about categorical data, we're always taking a look at, like, even though we do operationalize it with numbers, like usually in binary scale, 0 or 1, really what we're measuring is like differences between individuals, okay? And so like categorical would be like male, female, what kind of make a car is it? You know, there's a lot of different types of them, and so you just kind of have to go through these and kind of think about it. All right, and so first of all, letter grade here is quantitative or categorical. It's categorical, okay, because A, B, C, D, or F, those aren't numbers, right? Now, if it was percent, then boom, it'd be quantitative, but it's not. It's letter grade. Does that make sense? And then the next thing it asks you is the level of measurement. Now, these will always go in the same order, and so I'm going to just run through the different levels of measurement for you real quick. The lowest level of measurement is nominal data. Nominal means name. And so I'm going to tell you right off the bat, A, B, C, D, or an F. It's categorical. It could be nominal. All right, but it's not. It's actually ordinal because this is the next highest level. And next highest level is it's basically name data, but it has an established order to it. So a top 10 list, or in this case, A, B, C, D, or an F. And A is better than an F, right? And so that's actually ordinal. The next one here is interval. Interval is where there's an exact difference between each one of them, but that's only if it's quantitative data. And so that's the trick here. If it's categorical, it's going to be just this one or this one. If it's quantitative data, it's going to be this one or this one. Okay, and so let's wait till we get a quantitative one before we explain those. So here we go, occupation. Okay, occupation is it's not quantitative, it's not numerical data, it's categorical. And guess what? We're not going to sit here and rank order occupation. We're going to say, well, a nurse is way better than a teacher. No, we're not going to do that. And so it's just nominal based data. It's name data. All right, temperature, degrees in Fahrenheit. So temperature here, of course, is quantitative because it actually does have a numerical value to it. And this one's going to be interval, and I'll tell you why it's going to be interval. Interval data is quantitative data that has an order to it, where the difference between one category as opposed to the next is set by a set interval, in this case degrees Fahrenheit. So 1 degrees Fahrenheit is the same no matter you're talking the bottom of the scale or the top of the scale. Okay, and so this one is interval. Now, why isn't it ratio? Well, ratio data is very straightforward. This is the highest level of data out there, and ratio data is quantitative data where 0 actually means nothing. Okay, so, and what I mean by nothing is like, so the amount of money that you have in your bank account is ratio data, because if you have $0 in there, it means you're broke. Okay, so whereas temperature, think about it, degrees Fahrenheit, 0 doesn't mean anything. Okay, so yeah, we have above, below 0 and below 0, but it just means it's cold. All right, it means it's cold enough. You know, you're going to want a jacket kind of thing. But it doesn't mean there's no temperature, okay? Now, Kelvin scale, where 0 actually means there is no subatomic electricity or activity, that actually means 0, all right? But with Fahrenheit or Celsius, 0 doesn't actually mean anything, all right? It just means, yes, you got it. Kelvin would be a ratio. You got it. So, yes, but that is the point, okay? Whereas, like, even Celsius, where 0 means, okay, that's where water freezes, it doesn't mean there's no heat, okay? So it means it's cold enough for water to freeze. So that one would be interval as well. And be careful with that because they do throw those at you in here. Let's see if we go ahead and get one. So there we go. Check. Next one. Amount of fluid in ounces. So amount of fluid is quantitative, dispensed by a vending machine. This one's going to be ratio because 0 means that it does not dispense anything. Okay. Customer satisfaction rating. So this one's going to be categorical. So with very satisfied, somewhat dissatisfied, see how this has an order to it? So this is ordinal data. Color vision status, being colorblind or not. This is categorical nominal, okay? So, because notice that we're not saying, hey, it's much better that if you're colorblind than if you're not, okay? So my favorite example of this one is like, you know, and I see people do this every now and then where it's like, you know, ratio or number of men or women in a room, and if you click ordinal, it's like, okay, really? So which one of those two is better? Why don't you go ahead and say that out loud right now? so just be careful when everything is ordinal. It has a rate. It has a judgment aspect to it where one of these is better than the other. Whenever it's nominal, okay, that's where, no, we're not making judgments between these two things. So whether it be, you know, disability status here or race or, you know, political affiliation or whatever, or whether or not you're a Jets fan, you know, any of those things. All right, so remember, when we're not making judgments about those, it's just either yes, you are a Jets fan, or no, you're not. That it is nominal data, just like this right here. Yes, you are colorblind. No, you are not. So there we go. All right, I hope that makes sense. Sometimes these do take a little bit of practice. All right, but let's do one more. Gender, so perfect. Yes, this is categorical. It is not ordinal. It is nominal. Okay, so yeah, just think about that a little bit. It should make a little sense why that would be nominal. All right, temperature degrees in Celsius. So here we are in Celsius. So this is quantitative, and this one's interval. Okay, closing price in dollars of a stock. So this is again quantitative. This one is ratio because 0 actually means nothing. So can a stock actually close at $0? Yes, it can, which just means that you absolutely lost everything you put into it. Cool. So there we go. All right, so that's the different types of data that we have there. All right. Let's see. Trivia time, and then we'll do one more, and we'll call it quits today. So early day today, just because we really don't have that much to talk about. If you're on track with me, you're in really good shape. And so there is no need to stress out about this stuff. All right, here we go. Oh, okay, here's a great one. So this is an excellent question. I think someone was asking earlier that we wanted American food trivia. Amount and fluid of coffee in a cup dispensed by a vending machine ratio data. So, because 0 would actually matter. Yes. Let's see. Anyway, we wanted a piece of Americana here. Here we go. When was the fast food chain McDonald's? When was the first McDonald's founded? When was the fast food chain McDonald's founded? Go! So there's a great movie on there about this out there. Come to think of it. It's got Michael Keaton in it. So, ooh, that's not the answer that I've got. So that's close. So we might have to Google it to double check, but that's not the one that I got. I got 1955, Aiden. That's what I got. So let's go find out. So I think that was a pretty good guess there. When was McDonald's founded? So April the 15th, 1955. That's what I got. So yeah. So almost. Oh, you almost had it by memory. Oh, okay. Did you see that movie too, or are you just kind of a Mickey D's fan? So it's okay. So I do appreciate you to just, if it's something something you can bang it out, you'll beat everybody every single time. But at the same point in time, you got to get it right. So yeah. Oh, what's the name of that movie? It's about Ray Kroc. I think it's CROC. KROC. What's the name of the movie that they made? I just saw this not too long ago. Movie. What is it? Yeah, me too. Me too. So I am definitely... The Founder. There we go. Wait, who got it? Aiden got it. Aiden got it. Yeah. Aiden's got it, 1955. Look, I know it might show up on your side as you got it before there. It always favors what you're doing on your end, so your comments do show higher than other people's. So I got to use the log here, and so that's Aiden. Aiden, you got it. Sorry, I know it's disappointing, but it's just the way that YouTube kind of works. So, because of course it's like, on your end, you have an upload speed that's different than somebody else's upload speed and stuff. I know, sad day. That's okay. He's eliminated. We're going to do one more here in just a sec. Maybe you'll get that one. So, it's okay. So, anyway. But yeah, that was a good movie. Check that one out. If you're interested. What is this? Linear relationship and the sample correlation coefficient. Blah. We're not going to do that. Yeah, it does. Everybody's got a different upload speed. It's just, it doesn't do that. That's why we can't do, what is it? I used to make Kahoots all the time. Cannot do them on YouTube. Everybody gets completely jacked up. Oh, not fair. I wish that Zoom had like a poll thing that we could do, but it just doesn't. At least not one that I can find, but maybe we'll do something like at some point in time. Right now, Wednesdays are just kind of like, hey, show up, and if you need help with something, I'm here, so you can knock out problems real fast. But maybe we'll see how the rest of the semester goes. Maybe we'll find something else to do here. But I think trivia works pretty well. So yeah, exactly. You got the next one. That's the point. If you're here, you're gonna get paid. Eventually. All right. So let's do one more, and then we'll do our trivia. We'll call it quits for the day. Let's do this one: discrete probability distribution basic, and then we'll save these binomials for next week. So now this one when people get this one freaks them out, okay? Because you're like, what the hell? What is all this, okay? These are actually a lot more simple than they look, all right? So discrete probability distribution, remember, discrete just means count, okay? And so what we actually have here is we have a table where we have the value x of x, and so any givenly randomly chosen, you know, any randomly chosen observation of the given variable of x. Ugh. The probability that value would be -4 is 10%. That's what this is telling you. This is just p probability, okay? And this is the actual value of x. And so the probability in this givenly whatever hypothetical random distribution is basically saying our value of pulling one out from random, that the value of that random value being -4 would be 10%. Okay, so of it being +3, it'd be 18%. Of it being 4, 5, and 6, we don't know 4 and 5, but we know 6 is .20. Okay, and so you look at this, and you're like, well, how do I figure those two things out? And you read the descriptions in here, and it doesn't help you at all. Okay, because you're like, well, I don't get how you got that, you know. So, but here's the key to this is that, you know, when we're talking about a probability distribution, remember, it's a distribution, and reading it from left to right, all right, where we actually have the different values and the way that they're actually distributed across this, which will become more important. But just understand, at one end of it, eventually we have our minimum value, okay, and so the value of getting anything lower than that minimum value is 0. And then on the other end, we have our maximum value, all right? So whatever our maximum value, all right, anything to the left of that has to include everything because that one's our maximum. So we have 0 on one end and 1 on the other. So regardless of how far spread out this is, the total distribution of probability underneath the curve is 1. So it's 100%. All of the observations will fit under that curve at some point in time. All right. So the value, you know, anything less than our minimum value, the probability of that is 0. Anything less than our maximum value, the probability of that is 1. Okay. And so that's the trick to these. These just have to add up to 1. That's it. It's really that easy. And so you can go in here and you can put whatever you want in here as long as all 5 of these add up to 1. So here's how I do it. I take 1 and I subtract everything out. So .13, that one, minus .19, that one, minus that one, which is .22. Gives me .46. Just take that, chop it in half, and there you go. You can put it in both. Okay? Check. It really is that easy. So all you have to do is find some combination, all right, of whatever 2 answers are left here so that all 5 of these add up to 1. That's it. And that's all this problem is trying to teach you, is that the probabilities of any given value existing, add them all up, they will always equal to 1 in the long run. Okay? That's all this problem is trying to teach you, even though the explanation is terrible on it. So here we go. Let's do it again. 1 minus .27 minus .13 minus .19 gives me 0.41. See, this one's odd. And so, I mean, I can take it and split it in half like that, but just to demonstrate it, I can do 0.20 on this one and 0.21 on this one, because that adds up to 41 right there. Check. See, it works too. All right. So as long as everything in these adds up to 1, that's all this problem is trying to show you. And again, yes, the explanation for it is stupid. And I know it's confusing. And in class, this is one where people are like, what am I supposed to do? And the answer is, don't worry about it. See, this is .31. We can do it like this. .30 and 0.01. And it'll work. It'll take it. Oh, no, it won't. Boo! Oh, I made a liar out of me right there. Maybe I did my math wrong. Let's try it again. 1.28, .27, .13. Oh, .32. All right. So, my bad. I did fat finger something. There we go. But see, it'll take that too. All right. So, and fine, since I screwed that up, we're going to do one more here before we get out of discrete probability distribution basic purgatory. .27. What am I left with? .2. So we can do 0.1 and 0.1. So just take that, split it up amongst the 2, and there you go. Donezo. All right, so those are 3 easy breezy ones that you can absolutely positively just crush out in about 20 minutes. All right, so when we come back, because now you're going to notice that actually opened up. Oh, actually, we can do this one here. This one's actually really easy too. All right, so let's do this one, discrete probability distribution word problems here, and then we will, because we've only been doing this for 35 minutes, so let's kill this one off here, because once you get this one, then I think the only thing that's left are these binomial ones, and we'll save those for next week. All right, so let's go ahead and kill this one off here real quick. This one, all it's going to ask you to do is, again, understand that, you know, your probability always has to add up to 1, all right, and so this one's going to actually express it as a fraction based upon different types of outcomes in here, and so these are pretty straightforward. So here we go. We're going to toss coins here. And so this one's just going to actually take each one of these combinations here and express it as a value. And then we're going to actually translate that into a contingency table right here, and then figure out the probabilities for each one of these according to, I think it wants these as fractions, so we'll do them as fractions. So really straightforward. All you do is take a look at the values up here, and then you enter each one that's possible. Okay, so we have a -2, a 4, a -2, -2, -4, a 2, -2, a -4, and a +4. So we only have 3 different values in here that are possible. So put them in order. So our lowest one is -4, so we have a couple of those. We have a -2 in here, and then we have a +4. Those are the only 4 values that are actually possible in this table right here. Okay, and now we just figure out the probability of each one of those occurring. So -4 occurs 1, 2, 3 times. So that's 3 out of 8 total, because we have 1, 2, 3, 4, 5, 6, 7, 8 total possible combinations of heads, tails on 3 coins. And so then we just do the same thing with this one right here. 2 occurs 1, 2, 3, 4 times. And so that's going to be 1 out of 2. So, or 4 out of 8. Just reduce that down. You get 1 out of 2. And then this one here, 4 only occurs 1 time. And so that's 1/8. So if you added all these up, what do we get? 1. Yep. That's it. That's it. Easy breezy. So on all these, let's do another one. Here's boys and girls in the same room. All right, so notice that we only have 2 possible outcomes here. So values of x, we have 0 and -2. And so put my -2 in there. And put my 0 in here. And then how many times does 2 occur? It occurs 1 out of 4 or 2 out of 8. So 1 out of 4. Oh, check this out. Oh, scam likely. Haha. Yeah, right. I'm not falling for that. 1, 2, 3, 4, 5, 6. 6. All right. And so 6 is going to be 6 out of 8 reduces down to 3 out of 4, or just the complement of this. So 1/4 plus 3/4 gives me 1. All right. So that's the point between all of these. That's what you got to try and do. Make sure that this bottom row always adds up to 1. So all right, one more, and then we'll do some trivia, and we'll call it good. So, how many values of x? Notice I have 4 different possible ones here, and so I got a -4, a -2, a 0, and a +2. And so, -4, -2, a 0, and then a +2. How many times does -4 occur? Just 1 out of 8, so it's 1 out of 8. How many times does -2 occur? 1, 2, 3, so that's 3/8. How many times does 0 occur? Twice. 2 out of 8. So 2/8 reduces down to 1/4. 1/4. And then 2. +2 only occurs once right here. And so it's 1 out of 8. Like that. So 1/8 plus 3/8 is a half. Oh, I jacked this one up. Well, let's see. -4 occurs once. -2 occurs 1, 2, 3. 0 occurs 1, 2. Ah, there it is. So there's 1, 2, 3 zeros in there. So this is actually 3/8. There we go. So 1/8 plus 3/8 is 1/2, and then 1/8 plus 3/8 is 1/2, so that all adds up to 1. There we go. Always good to do your checks on these. Make sure they all add up to 1 down at the bottom. But that's it. That's all there is to these. This is just taking a value of x and assigning it to each outcome, and then we're just figuring out the probability of that actually occurring here. So don't think about this one too much. There's not any reason why this is -4. They just arbitrarily picked that. Okay, it's fine. Well, actually, it follows this right here, so but don't worry about that. You don't need to read that in order to get these right. All right. So there we go. Easy peasy. That's 4 easy. Yeah, you're right. It's 3 zeros. My bad. Yeah. Sorry. You get a little bit tunnel vision on what did I do wrong? And I don't always see that you guys are screaming at me over here saying, Pat, you're jacking it up completely. So that's okay. I do appreciate that. All right. So let's see. And see, that opened up a bunch more of these. Okay. And so the ones that you should do next after these are the binomial ones. Do the binomials before you start getting into these standard normal ones. If you start getting into problems here where you're seeing P's and Z's and C's, hold off on those. Okay. Just for a little bit. And, I mean, if you understand them, great. Go ahead and do them. All right, and I do have YouTube videos up on all of those. But at the same point in time, it's probably better that you do the binomial ones first. All right, just because if you understand how binomial problems, then understanding standard normal values after that is a lot easier. Okay, so hope that helps. All right, so here we go. One last food trivia question for the day. Let's see. No, that's gross. Oh, you guys all know what bees make. Come on. Oh, that's interesting. I wonder if this is true. Which vitamin is the only one that you will not find in an egg? Oh, I did not know this. Which vitamin is the only one you will not find in an egg? Go. So, I don't know if that's really a food question or maybe a nutrition question. And considering I'm a sucker for breakfast for dinner, we're going to go ahead and go with that one. So, yeah, that's good. That's correct, Guts. It's vitamin C. Oh, my gosh. Oh, so Harley. Oh, no, that was Lexi, who was just a little bit behind there. Oh, yeah, sorry, Harley. So, a little late to the party there. But, Guts, you got it. It's vitamin C. I did not know that. So, I guess it makes sense. So, because vitamin C only comes from fruit, if I'm not mistaken, correct? Yeah, I think so. I don't know. So, like I said, I don't know that much about that stuff. So, dang, yeah, I know. That's okay. We'll do more trivia coming up soon. So, but, you know, with Alex here in particular, make sure that you're at least keeping pace with me, because we will kill off. See, look at that. Just today, we got 4 of these done. And so we've got 2 whole more weeks to work on this purple slice. So by the time we get to we'll get through all the binomial ones very quickly, and then we'll get to the standard normal ones after that. So we'll be on really good track here. But if you are struggling with some of these probability ones and things like that, please ping me. Let me know. Show up on Wednesdays, whether it's on Zoom or whether it's in person. I will help you through these, because once you get going on these purple ones, they'll peel off the calendar really fast. All right. Next thing you know, you're on these reds. Okay, and so I don't want you to get too far behind, because I'll start, if I get to these not the reds, the blues here, and you're still back here on these, you're going to be very lost. You're going to be like, what is Pat talking about? Okay, so make sure you're pushing through the reds so that you're keeping pace with me on the purples here. That way, when we get to confidence intervals, hypothesis testing, it'll go real quick for you. Okay, all right, that's all I got for you today. Short day today, so a good 45 minutes in here, but like I said, it's not time to if you're on pace with me, it's time to take it a little bit easy and, you know, give yourself a pat on the back for doing such a good job. But if not, and if you need a little bit more help, I'll stick around here for a few more minutes and be happy to cover anything that you're working on. Otherwise, we can do that in person on Wednesday as well. All right, that's all I got for you today. So if you're good, I'm good. So we'll catch you all on Wednesday. But like I said, I'll stick around for a minute just in case you need some help too. All right, take care now. Have a good afternoon. Bye. 54 is great. You are doing great. Keep it up. So you're doing absolutely great. Keep it up. You bet, Morgan. You too, Lexi. Have fun. So we'll see you Wednesday. Yeah, piece of cake. Just do a couple of those that I did, and you'll be there. No problem. No problem at all. So very, very low stress. You too, Harley. So better luck next time. So maybe you tell me what you want to do next time. Were we gonna do Game of Thrones or something? I can't remember, but just let me know, and we'll make it happen. All right, about 30 more seconds. All right, 10 more. 3, 2, 1. See ya. See you Wednesday.